Hello, I'm Skip Elsheimer. Welcome to the AV Geeks lunchtime streaming show, where I did some math, thanks to Jeremy, and I figured out that we had mislabeled and miscounted the number of episodes that I had done. So that previous 400th episode that we celebrated wasn't true. We were off by 40 some episodes. So today was actually the 400th episode. Maybe. There's so basically I've been going off a list of titles that I've been trying to keep track of what films I've shown, which ones I haven't, so that I don't keep showing you the same films over and over and over again, because my memory has, I remember some things, but some titles I'm like, did I show that one? I can't remember. So that was what I was using to count. And Jeremy's going through and he's annotating what films I've been showing on which episode on YouTube, which has been really helpful. And he found a discrepancy, and I was like, oh, wow, I wonder how that happened. And then I realized, when I started counting the episodes, I was counting the days that I had done shows and not literally going and counting one, on YouTube, how many were there. And I noticed that I had accidentally included weekdays or weekends, which I had not done screenings for. So, anyways, this is probably a more accurate 400. But really, in the grand scheme of things, it kind of doesn't matter. I think we're just kind of looking at numbers and all that. It's more about just showing you the films and you guys enjoying them, commenting on them, etc. And that's what really counts. That's what counts, not the actual episode count that you're watching. And someone keeps mentioning, oh, well, you're going to have another 420 episode. No. Folks hated that episode so much that I was like, no, I don't think I'm going to do that again. And plus, I was running out of all the good films about marijuana. And so, yeah, we're not going to do 420 again. Maybe on April 20th, but I don't know. In the meantime, here's some 16mm films that we're showing that I have not shown before. This next one is called Mammals Are Interesting. Enjoy.
Of all animals, the most highly developed is a group called the mammals. Animals like the hippopotamus, the bear, and the chipmunk. In order to understand the mammals, let's look first at some of the simpler animals. These protozoa, so small they can be seen only with a microscope, are the simplest form of animal life. They are made up of only one cell. These sea anemones are made up of many cells. Although they can be seen with the unaided eye, they are also a very simple form of animal life. These are crayfish. They are members of a group of animals with jointed legs. Animals like insects, spiders, crabs, and lobsters. The crayfish are like the protozoa and sea anemones in one respect. They do not have backbones. This fish has a backbone. Although more highly developed than the animals without backbones, it is one of the simplest of backboned animals. Fish breathe with gills, and they are cold-blooded. That is, the temperature of their bodies changes with the temperature around them. This lizard belongs to a group of animals called reptiles, a group that includes turtles and snakes. Like fish, reptiles have backbones and are cold-blooded, but they differ from fish in that they breathe with lungs. Birds, like this pelican, have backbones. Like the reptiles, they breathe with lungs. But birds are warm-blooded. Regardless of the temperature around them, their body temperature stays the same. Here's another animal with a backbone. He's a giraffe, a member of a group of animals called mammals. Mammals may differ as much as this giraffe differs from these polar bears. But all mammals are alike in many ways. All mammals, of course, have backbones. Run your hand down the middle of your back. That bone you feel is a backbone. As this boy takes a deep breath, he can feel his lungs fill up with air. All mammals have lungs and breathe air. All mammals are warm-blooded. Although this beaver is swimming in icy water, the temperature inside his body is the same as it would be on a summer day. Two things make mammals different from all other animals. First, mammals have hair on their bodies. In fact, if an animal has hair, you can be certain it's a mammal. This cat and her kittens are mammals. Second, all mammals, like this sheep, feed their young milk, a food which is made by glands within the mother's body. This cow is feeding or nursing her calf. All mammals nurse their young. This baby monkey is hungry. He's looking for his mother. She will give him some milk. Only mammals, of all the different kinds of animals in the world, are able to give milk to their young. And only mammals, of all the different kinds of animals in the world, have hair on their bodies. These two things make mammals different from all other animals. Here's an animal called a sea lion. Sea lions nurse their young. Sea lions have hair on their bodies. They are warm-blooded. They breathe air with lungs, and they have backbones. Although they spend most of their lives in water, and although they swim like fish, sea lions aren't fish. They are mammals. There are many different kinds of mammals, and they may be divided into several large groups. One group, the hoofed mammals, like these buffalo or American bison, are plant eaters. The hoofed mammals, like these European fallow deer, have large, flat teeth with which to grind their plant food, and they chew it thoroughly before swallowing it. Many of the hoofed mammals, like this mule deer, have long, thin legs. Long legs and hard hooves are well fitted for running on hard ground, in open places. As you would expect, many hoofed mammals will be found in open places, where, like these American or pronghorned antelope, they use their speed to escape their enemies. Man has domesticated or tamed many of the hoofed mammals, like these sheep, in order to raise them for his own use. This sheep is a domesticated hoofed mammal. The hoofed mammals provide us with many of the things we eat and wear. Another group of mammals, called the carnivores, or meat-eaters, is made up of mammals that eat meat. This puma, or mountain lion, a member of the cat family, has long, sharp teeth with which he tears his food. Since he has no flat teeth, he cannot chew his food before swallowing it. All carnivores use their teeth to catch and kill their prey. Many carnivores also have sharp claws. A house cat is a carnivore, or meat eater too. Since a carnivore eats other animals, he must be quiet and quick if he is to catch them. A carnivore has pads on his feet to help him move quietly. Other members of the cat family are the tiger. Notice his teeth. And the lion. These teeth belong to a coyote. The coyote is a member of the dog family, another group of carnivores. Like all carnivores, the coyote has sharp pointed teeth with which he tears his food. The coyote, like the dog you have at home, is a meat eater. Perhaps you've wondered why your dog doesn't chew his food. Well, because his teeth are pointed, he couldn't, even if he wanted to. This is a familiar mammal. He's a rat, of course, one of the gnawing mammals, or rodents, the largest of all the mammal groups. Many of the mammals most familiar to you are rodents. By looking closely at a rodent, like this squirrel, you can usually tell something about his way of life. Notice his long, bushy, balancing tail, and his short, hand-like front paws, well fitted for climbing. Perhaps you've noticed a fresh mound of earth right in the middle of your lawn. Here's the fellow who's probably responsible. He's a gopher, and he, too, is a rodent. His long, chisel-like front teeth are just right for cutting up roots and stalks. With his large, flat back teeth, he grinds his food before swallowing it. He lives in tunnels, which he digs underneath the ground. Notice how he pushes the dirt with his front paws. When he's finished his tunnel, he plugs up the entrance with dirt. Perhaps the most interesting of all mammals is the group called the primates, a group that includes man. The primates, like this chimpanzee, are the most intelligent of the mammals. Like man, they have flat nails instead of claws, and hands, which they use for grasping. Their teeth are like ours, fitted for both tearing and chewing. Though most primates prefer a diet of nuts and fruit, they are able to eat both plant and animal food. This gibbon is a primate also. Like all mammals, gibbons have backbones, lungs, warm blood, body hair, and are able to nurse their young. Basically alike, yet different in many respects, mammals are interesting animals.
So the irony here is, while we were watching this film, I was off dealing with some other mammals that are invading the archive, and had to set some mouse traps and empty some mouse traps. We used to have a cat here at the archive, which took care of that problem, but now we don't. So I have to deal with this. So, anyways, yeah, not rats, mice. Thankfully, we've had rats. Like when I first moved into this space, there were rats, but we don't have rats anymore. Speaking of fire, here's a film called Fire Science.
It's not hard to imagine that primitive man, 500,000 years ago, trembled before the anger of his god of fire. But even then, 500,000 years ago, Stone Age man had learned to make this fearsome thing called fire his servant. Sheltered in his cave, he learned to provide light and warmth even against the advancing glaciers of the ice ages. He learned that fire could make his meat taste better, and would frighten off the savage animals that hunted in the night. Many thousands of years later, nobody knows just when, people learned that fire would harden the clay of their crude pots. At last, the dawn of history and the age of metals. Bronze Age man learned to smelt metal ores in a primitive furnace: copper, tin, zinc. He learned how to burn charcoal to reach the extremely high temperatures needed to melt the metal. Now, instead of chipping an axe head out of stone, he had a new material that he could cast into the shape he wanted. But for many centuries to come, he learned no other ways of using fire. It is true that about 2,000 years ago, an early scientist named Hero used fire in an entirely new way. He made an engine that used fire to turn water into steam. The power of the steam made the machine go around by jet propulsion. However, Hero never used his machine except to amaze the citizens of Alexandria. Imagine how different things might have been if the Romans had been ready for an industrial revolution and had learned to make machines work for them. Maybe it's just as well that they didn't. Today, we've learned to use fire to help us in 1,000 ways. Burning gasoline and diesel oil run our cars and trucks. Burning coal, oil, and gas light our cities and provide power for our factories by turning gigantic turbo generators to make electricity. Vast quantities of coal are heated without air to produce coke, the fuel that we use in the making of steel. It is coke that is burned to heat the steel in our blast furnaces. And like primitive man, we too control fire and use it to cook our meals. What is this strange burning process that makes so much difference in our lives? What is fire? You know one of the things needed for a fire: some kind of fuel. However, you'd hardly expect any of these fuels to burst into flame unless something else happened. You might say that we have to set fire to them. Scientists are more precise. They say that in order to burn, a fuel must reach its kindling temperature. As you know, one other thing is needed in order for a fuel to burn: oxygen. If air is kept from a flame, it will go out. The less air, the quicker it goes. The part of the air used in burning is oxygen. When we blow a jet of oxygen into the flame, the fuel burns brighter and faster. What happens when something burns? The fuel in this candle, the paraffin, is made up of molecules. We'll picture the molecules as round dots, although they're not really round. These molecules are constantly moving even before the paraffin burns. If we heat the fuel, the molecules move faster. The paraffin melts and becomes a liquid. As the fuel gets hotter, the molecules become a gas and fly off into the air. This is when burning begins. Let's stop all this activity and see what one of these molecules consists of. Paraffin is composed of different complicated molecules made up of many atoms of carbon and many of hydrogen. Most of our common fuels are composed of these elements: carbon and hydrogen. Now let's say that this molecule flies off into the air as a gas. Some of the molecules in the air are oxygen molecules, each made up of 2 atoms of oxygen. Two oxygen atoms and a carbon atom attract each other and combine. This is called oxidation. This new kind of molecule is a carbon dioxide molecule. Di means 2. 1 carbon plus 2 oxygen. A chemist writes it this way: C plus O2 forms CO2. Every time one of these new molecules is produced, a little energy is released in the form of heat and light. Multiply this billions of times and there is enough heat and light to make what we call a candle flame. The hydrogen atoms oxidize too. That is, they combine with oxygen. But in this case, 2 of the hydrogen atoms combine with 1 oxygen. The chemical equation for one of these new molecules is H2 plus O form H2O, or water. We can cause a film of water to appear on the inside of the glass. Water that is formed when 2 atoms of hydrogen combine with 1 atom of oxygen. Again, energy is released when these water molecules form. Many substances that burn form these 2 compounds: carbon dioxide and water. You can see why the oxygen from the air is necessary for the burning process. No oxygen, no formation of new compounds, no burning. Anyone who has tried to light a fire without enough paper or kindling wood knows that a combination of fuel, oxygen, and heat doesn't necessarily result in a fire. The reason the wood doesn't catch fire is that it doesn't reach its kindling temperature. Different materials have different kindling temperatures. Here is an experiment. We'll test the kindling temperatures of paper, a match head, wood, and a piece of unburned candle wick. Watch the order in which these materials ignite. First, the match head, then the paper, the candle wick, and finally, the wood. There are some materials, such as those in this match head, that catch fire with only the heat that comes from a small amount of friction. This was photographed in slow motion. There are materials such as phosphorus which must be kept under water because in the air, even at room temperature, the atoms of phosphorus combine with atoms of oxygen, producing heat. The heat gradually raises the temperature of the phosphorus until finally it ignites. This is a particularly dangerous material because it spatters fiery particles when it burns. Paper has a low kindling temperature, as everyone knows. How is it possible to put a paper cup over a Bunsen burner flame without its catching fire? It's because there is water in the cup. The boiling point of water is 212 degrees Fahrenheit, which is below the kindling temperature of paper. The water absorbs the heat and keeps the paper cool, at least too cool to burn. Here's something else to think about. It's not easy to ignite a piece of wood with a match. But shavings burn quickly, although they are both the same kind of wood with the same kindling temperature. The difference is surface. The shavings have more surface exposed to oxygen in the air. There is even more surface exposed when the fuel is one such as gasoline, which gives off vapor at room temperature. You can see this vapor, which is heavier than air, actually pouring over the side of the beaker. Gasoline will catch fire from a small spark because the tiny drops of vapor are thoroughly mixed with oxygen molecules ready to burn. This dangerous experiment should not be attempted. You can understand why a fuel that vaporizes is so very dangerous. Another dangerous kind of fuel is one such as boiled linseed oil, which can catch fire by spontaneous combustion. In this experiment, we have soaked cotton in linseed oil and have filled a can half full. We will put metal foil over the top and surround the can with insulation to cut down the amount of heat that escapes. Small holes in the metal foil will let in oxygen. When the experiment starts, time will be speeded up with a special camera. A watch will keep track of the speeded up hours. A round dial thermometer measures the temperature, 85 degrees Fahrenheit, 90 degrees. Even at room temperature, linseed oil slowly combines with oxygen, producing heat. Because most of the heat cannot escape through the insulated walls, it is stored up until the kindling temperature is reached. Watch. This is spontaneous combustion. This experiment, like some of the others in this film, is extremely dangerous and must not be done by students. Thousands of homes have burned because oily rags have been piled carelessly where they catch fire from spontaneous combustion. Fire in any form can be dangerous, and when it gets out of control, it causes countless tragedies. But fire under control is one of mankind's great servants. We are continually learning ways to make it work for us. The power of fire can do much good, and we must learn to control it well.
I love that film because it shows us this really awesome thing, and then it tells us, yeah, you shouldn't do that. Here's how we did this awesome thing that caused this spontaneous combustion. Yeah, don't. Yeah, we don't think you should do that, though. I mean, that's the thing about a lot of educational films, is that they show something and then they say, no, you shouldn't do this. And yet there it is, they're showing you how to do it. That's always the problem with drug films, or with films like, I've always thought that cafeteria manners films, when they show a food fight, it's like, oh, cool, I can do a food fight. Even though they're trying to say, no, don't do a food, but there it is. You can see how to do it. All right, so behind me is a reel of film. And so this last film I showed, Fire Science, Churchill Wexler. Wexler did a film called Squeak the Squirrel, which is probably one of my favorite films. It's about a squirrel. It kind of shows how squirrels can learn how to use tools and learn how to get these little peanuts. That was originally shot by Lester Beck, who was a psychology professor at the University of Oregon, and he shot it in 1942 as a way to kind of show how animals can learn. And then he worked with Wexler Films, Cy Wexler, to edit it and make it for a kids thing, and which was wildly popular. But Lester Beck also did other fascinating things, and he also did an educational film called Human Growth, which is basically shows where babies come from in the 50s, and it's really smart and great. And I think it was actually bankrolled by Eddie Albert from Green Acres. But so this next film is fascinating. Shot in the 50s, I believe, and let's just watch it. It's long, but it's pretty interesting. So here's Hypnotic Behavior.
Once the subject is well hypnotized, he can be given a wide variety of suggestions, which he will readily accept. In a deep hypnotic sleep, the subject can be made temporarily blind or deaf, or can be made to see and hear things that are not there.
Isn't that mysterious?
Well, no. It says here, there's nothing mysterious about hypnosis. It is simply a highly suggestible state into which the willing subject is induced. The subject selects the suggestions to which he will respond, which means that he really hypnotizes himself.
You are drowsy, so drowsy, relaxing more and more and drifting into a soft, quiet, restful sleep. Your eyelids are becoming heavy, so heavy. You are sleepy, sleepy and drowsy. Now relax completely and go sound asleep. Relax every muscle and drift into a deep, peaceful sleep. Going sound asleep, sound asleep. Going into a deep, profound sleep. So drowsy, so sleepy, so relaxed. Going into a deep, restful sleep. Going profoundly asleep, deeply asleep. Your heads are so heavy you cannot hold them up any longer. They are slowly falling down on your shoulders, falling down on your shoulders. They're so heavy. You are going profoundly asleep, deeply asleep, 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 deeply asleep, profoundly asleep, 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 going deeply asleep, asleep, profoundly asleep, asleep. Now, Claire, are you sound asleep? Claire, are you sound asleep? And Don, are you sound asleep?
Yes.
Sound asleep. Now you will raise your heads and sit up and remain sound asleep. Sound asleep. Raise your heads and sit up and remain sound asleep. Sit up in your chairs and put your hands on the table. Remain sound asleep. Don, sit up further. Sit up further. Put your hands and arms out on the table. Raise your head a little, Don. Now your eyelids are sealed tightly together. You may try to pull your eyelids apart, but you cannot. Try hard, and you see they're sealed tightly together. Try to pull them apart. Try harder, and you cannot pull them apart. Now relax. Relax. You can see that your eyelids were sealed tightly together. Just relax. Now your arms will become stiff and rigid at your side. Claire, it will be your right arm. Don, it will be your left arm. Your arms are becoming stiff and rigid, stiff and rigid, stiff and rigid, and lifting from the table. A little higher and a little higher. Hold them there. All right, relax and put your hands back on the table. Don, will you sit up a little closer to the table? Now put your hands together and move them over towards the edge of the table. Claire, move your hands out and forward. That's right, over towards the edge of the table. All right. Now your hands will become insensible. Claire, your right hand is now insensible. Don, you no longer feel pain with your left hand. And you will not feel anything until I tell you that your hands are normal again. Now your hands are normal. Let's test them again. Claire, will you put your hand back out there? Move it over. Now your hands are normal again. You will now raise your heads a little higher, little bit, and open your eyes. Open your eyes and remain sound asleep. Open your eyes and remain sound asleep. Look straight out. Don, here is an exotic perfume. How do you like that, Don? Claire, reach over and get the glass. Look down at the table and reach over and get the glass and set it down in front of you. Now, Claire, that contains a foul odor. Just sit there. Now it's going to change. It's going to change. It's a very sweet odor now. And you're going to sip the substance. You'll sip the solution. See? How do you like that? How does it taste? Thick? What is it? It's syrup? All right, Claire, will you move the glass back to Don? And give Don a drink. Don, this is a very bitter solution. Don, move over and take a drink. Put the glass over by your left hand. Move the glass over. Now that was just water that we were giving you, Don. You no longer have a bitter taste in your mouth. It's all right. See? What does it taste like now? Is it gone? The taste is gone. Claire, between you and Don is a pencil. Look down at the pencil. You see the pencil? Now that pencil is going to change into a hot rod, a hot piece of metal. Not too hot. You'll pick it up and touch Don on the hand with it. Do that. Don, put your hands back out. It isn't that hot. Put your hands back out on the table, over towards Claire. Put your hand back out there. Claire, will you pick it up and touch Don again? Now that was only a pencil that you were being touched with, Don. Put your hands back out on the table. It was only a pencil. It's not hot. It's not hot at all. Now, Claire, pick up the pencil again and touch Don with it. See? It was only a pencil, and all the pain is gone. You feel all right, Don? Yes, it was only a pencil, wasn't it? And it's no longer hot to you, Claire? No, it was only a pencil. Now we're going to touch you on the shoulders. And when you're touched on the shoulder, you will become deaf. When you are touched on the shoulder a second time, your hearing will return. Do you understand, Claire? Do you understand, Don? All right. Just relax, relax. Don, you are becoming blind. You're becoming blind. You no longer see anything. Now your vision is returning. It is normal again. All right, Don. Sit up normally. Now you are going to awake. I shall count to 5, and you will be wide awake. A few moments after awakening, you will be given a pencil. You will write with a pencil on a blank sheet of paper that is on the table in front of you. Later, when I say sweet dreams, you will go to sleep again. You understand, Claire? When I say sweet dreams, you'll go sound asleep again. Don? Don, do you understand? All right, close your eyes for just a moment, and then I'll awaken you. I shall count to 5, and you'll be wide awake. 1, 2, you're slowly beginning to awaken. 3, you're awakening more and more. 4, and 5, and your eyes are wide open. Well, how do you feel?
Fine.
Okay.
How long have you been asleep?
Long
Quite a
time.
while.
How do you know?
I don't know, I just feel that way.
How long do you think it has been?
Minutes?
Yes, or hours.
Hours.
An hour, more than an
At
hour.
least an hour. 2 hours, maybe.
It's been a long time.
Do you remember anything that I told you while you were asleep?
No, I don't think so.
Do you remember anything that went on? You don't remember tasting anything or being burned?
No.
Not a thing.
What are you doing?
I don't
Why are you writing?
I don't know. I just feel as if I should.
Doodle.
You just feel like doodling. All right.
Oh,
Sort of nervous. I mean.
You can go right ahead. What have you written there, Claire? Mind telling me?
no. It doesn't make sense. Long and hard.
Long and hard. You don't know what it means.
I start to write long.
Yes. Don, what have you written?
Cool, cool water.
Cool, cool water. Well, sweet dreams. Just relax, Claire. Relax, Claire. Would you like to sit back in the chair? Are you sound asleep again? Don, are you sound asleep? Claire, will you sit back in the chair a little while, please? And put your head back. Now you will awaken again. After you are awake, you will be given a picture magazine to look at. Claire, for you, the pictures on the left-hand pages will be very amusing, while those on the right will be depressing. Don, for you, the situation will be reversed. The pictures on the right-hand pages will be amusing, while those on the left will be depressing. Do you understand? Do you understand, Don? Claire, do you understand? All right. Now I shall count to 5, and you'll be wide awake. Be sure to study each page carefully. Ready? 1, 2, 3. You're awakening more and more. 4 and 5. You're wide awake. Hello. How do you feel?
Fine.
How long have you been asleep this time?
Pretty long.
How long would you say?
No.
How long would you say, Claire?
I really couldn't say.
Oh, I see.
Quite a while.
Quite a while.
You like a little? Well, what's funny about that?
Oh?
Did you ever sleep in a pair of tight pajamas?
No.
You wouldn't know.
Oh, look at that.
For every scar on his face, she wore 2 on her heart. Doesn't that touch you?
Very.
Price is a perfume.
Yes. Oh. Now this.
What about
That
it?
makes me so mad, I could spit, and there's nothing I can do about it.
I think they look ridiculous.
Well, they look ridiculous, but
Well, they are.
what they stand for is very menacing. I don't
They
like
still
it.
look funny.
They may look funny, but they're deadly. They hide
Yeah.
behind a mask of patriotism.
What do you think about baseball?
I'm not at all interested, to tell you the truth. Occasionally, if it's a good game, I like to watch it. I don't like to listen to it over the radio.
Look at
Not-
that.
It's not
There's
very
some
often I watch
real
it.
good action shots there. Look,
That's sort of good, though. I mean, when things
Uh-huh.
like that happen, I like to watch a game.
yeah. But look at that. Isn't that something?
All these...
The expressions here in the faces. That's really a nice shot. It really is. What have we here? Look at him. Look at him. He looks like Esky on the front of Esquire, you know? Almost.
Look at all her clothes. She's getting all prepared.
Kid. This is quite a story.
Oh, what a hassle that must have been.
There's somebody going over here.
Oh, good. It's pitiful. I've yet to
After a
see
television party.
after any party. Oh, I kind of like it. Well, it depends on
It's
what.
not functional.
Not functional. That's all it is. It's functional. That's nice looking. Oh yes, I saw this about you.
I get it. Some of you hated that. You really didn't like that. It's fascinating to me, and I did cheat and add some ambient background music. There's an ambient music generator. It's called Black Hole Interactive Soundscape Generator that just runs in the background. So I apologize if some of you fell asleep. I apologize if some of you were like, this is just going on forever. But thanks for tuning in, and you're welcome to complain. Write a letter to the editor. But every once in a while, I like to watch a film like this. That's just kind of, it's meditative and hypnotic for different reasons. There's some question about how real this was, and I don't know. I haven't done enough research to tell if this was disproved. But Lester Beck, hypnotic behavior, look it up, do some research, and go towards the academic journals that talk about this in his experiments. This is the same guy who did Squeak the Squirrel, so there's a tiny little bright spot in my heart for this filmmaker. Anyways, if you like what you saw, or if you didn't like what you saw, you can buy us coffee. Either way, to reward us or punish us, at buymeacoffee.com/avgeeks. And you can also go to avgeeks.com and see other shows that we did, including the other 400th episode that we did about a month and a half ago, or 2 months ago. And you can also tell the world that you like us, even if you don't. Just pretend like it by hitting the like button or the thumbs up button, or hitting subscribe. All those things help, because I won't be showing these films all the time. I'll show you a lot of short stuff. I got a lot of fun short stuff, but every once in a while I gotta bust out something that's a little bit longer. And I think you all liked it at the beginning, right? Anyways, thanks again everybody for tuning in. Look inside the film can to give you some advice, and it tells you to please rewind and love each other. And we will be back tomorrow, 1 o'clock. Everybody take care.